Hey everyone, welcome back to MLworks. In this video, we'll be understanding SHAP, which is a Python package for understanding or interpreting the model's prediction. So basically, when you train a model, so you have a bunch of features that you are passing it to the model along with the target variables, and these two interact and get you some kind of final prediction. Now, during this interaction phase, it tries to understand which features contribute towards the final output. Okay, so with the help of SHAP, what we'll do is we'll understand how they got interacted and how they are able to push the prediction towards the actual model output. Okay, so consider right here you have a black box model and you pass in a four input features you have, and then you have a final output of 0.4. Now there is a base rate of 0.1. The base rate refers to the average final output predicted by all the samples. Okay, so when you have such a model, okay, what you do is once a model is trained or fitted, okay, you pass that to your SHAP package or explainer, and it will try to understand how these features got interacted and which contributed towards the final output. So if you, in this case, if you can see here, so age gave some kind of 0.4 contributed towards that final output, and sex related to -0.3, and then BP and BMI 0.1, 0.1, and they finally contributed towards the final score of 0.4. Okay, now what we'll do in this video is we'll take in a house price data set and we'll have some bunch of features, and we'll try to understand how those features interact with each other to get the final housing price prediction. Okay, so let's get started with the video. So first we import the package, in this case XGBoost model, and then we'll be using SHAP. And what we do is from SHAP we take in the housing price data set and get our features and target. Okay, so let me run this. So here we have our features. There are around 20,000 plus records and 8 columns. So there are median income, house age, average rooms, bedrooms, population, average occupation, and then latitude, longitude. Okay, so this is with respect to the features. Now they interact together and they give you a final output, which is target, which is in this case is Y, and this is in hundreds of K, and this is 0.45, 0.35, not 0.35, 3.5 and 3.2521. So this is your final prediction that you are getting. Now what we do is we try to fit our XGBoost model on top of this data set and get our model. So this is a model which has been trained now. Okay, now what we do is we use this trained model and send it to an explainer from SHAP, and this will generate our explainer. Okay, so this will understand how the features interacted to get the final output. And now what we do is, so since it understood that, now what we do is again we pass the input, which is X, and pass it to the explainer. Now what this will do is it will try to understand how each of those features in each data point contributed towards the final output or the final prediction. Okay, and which results in something called as SHAP values. Now if I do this, it will generate the SHAP values for all the 20,000 records, and for each of those features it will generate the SHAP values. So let me run this. So yeah, you will see 20,000 plus records that are present, and for each record there are 8 columns and each column has one SHAP value. Now that will each SHAP value, when you combine all the SHAP values together, you will get the final prediction. So let us understand how this looks like, right? Since we have so many records and we have so many columns, so let us understand with the help of plot how each of those features contributed towards the final prediction. So first what we'll do is we'll plot waterfall plot, which will tell you exactly how each of those features contributed towards the final prediction. So let me run this. So here if you see there is something called as base value, which I mentioned earlier, which is the average of the predictions made by all the samples, and then we have SHAP values, which is generated for each of the features. Now, what I'm doing here is I am just plotting SHAP.plots waterfall, and I'm taking just one sample and understanding how that one sample's features are going and predicting the final output. Okay, so here in this plot you will understand there is a base which is EF of x is equal to 2.068. Now each of these features will go beyond base and less than base. Okay, so here if you see this is the base 2.0 and there are plus which is 2.01, 2.02, okay, or 2 point, or this, when you add this one, this will be 3.71. okay, and if you take into this into account, then it will be 1.95. okay, so that's how it is calculated. And here in this plot you are seeing the 8 columns and their corresponding feature values, and this is the, what you call it, the base value and its range, okay, which in terms of prediction it is between 0.2 to 2.0 to 4.0. okay, and here there is like beyond it's 5. okay, now each of these features, if you see each of these rows, okay, median income contributed around 1.71. This longitude contributed 0.56. Similarly for other columns. Now these are the positive impacting features, and when you add them together and subtract these 2 points, you will get your final housing price prediction, which is 4.199. okay, so this is how it understands how each of these value contributes towards the final output. So basically, the greater the median income, the greater will be the housing price also. So basically, as I said, here I have mentioned it, 1.71, 0.56 minus 0.39, and if you keep adding all these values, you will get the final output or final prediction. Now this is one way to look at the results. There is something called as force plot as well, which will give you the similar information but in a different format. Let's understand this. So this is for 100th sample. We are trying to understand which feature contributed what. Okay, so here you will see population contributed around, this will be point between these 2 points, right, whatever it is, 0.4 or 0.5. And here from here to here this is 0.6 or almost 0.5 or 0.4 values or 0.6. okay, so if you want to understand this one, right, let me this is a 100 sample. I'll just do 100 sample here also. So you will see longitude, it is 0.68, okay, which is this one, 0.68, okay, this is the largest value. And then average occupation 0.59, which is this one, okay, 0.59. okay, and similarly these are like negatively impacting, you will find them here. Okay, so this is one way of predicting, understanding the features which contribute towards your final prediction. And here for the 100 sample, the median score, median housing price was 2.32. Now this is for one sample. Okay, now what you have to do is, if you want to understand for 100 samples or 500 samples or all the samples, okay, what you can do is, we can rotate this plot, okay, such that you can combine a bunch of samples together and understand the plot. Okay, for that what you have to do is, just instead of putting one value, you can put in a different index, okay, 100 colon 100, and it will give you 100 samples. Okay, it basically tries to rotate this particular graph that we have here, this plot here, and it will try to rotate and combine all the samples together in a horizontal way. So let me run it. So here you will see we have our f of x, which is our final kind of an objective function. Okay, and you have all the features along with it, and then we have all the samples here, and here it is sample order by similarity. So the samples that look similar in nature, they are like similar together. Okay, or sample order by output value. Okay, when their output value is similar, then they are combined together here. Now what we want to understand is, let me just pick one of the value, which is median income, and then we can notice how each of in this range, okay, what is the latitude and longitude. Okay, they are like, if you see here, it is, if I am able to look at here, if your median income is 7.257, your latitude and longitude are like this value, and you will also notice that average rooms are like 8.2, okay, in this case. And if I can scroll here, okay, here if you are noticing, okay, here if you are noticing, it is 6.118, and your average room is 6, population is 86, and I'm guessing if you have like lesser population. If the area is like elite kind of an area, you will have lesser population, I hope. Okay, so then as this median income reduces, I guess here, okay, the number of average rooms will also decrease. Okay, and this is the average median income of 1.321, and then average rooms, I'm not able to see what is the average room here, 4.21, 4.7, and then here if I can look at, okay, so it is also averaged. Actually these values are also averaged because it is not plotting it. If you can see here, it is averaged for 5 samples. It is averaged all these values that we are seeing. Let me see like some good one with the more average. Okay, 8 samples are there with 2.563 as the median income, and the average room is 4.6. Median income is 2.601, and then we have latitude and longitude, and then average occupancy, or I'm not sure if it is occupancy or occupation, it is 2.83883. Okay, so this is how you can combine all the data points and understand how each features interact with every other feature. Also, let me just put here one more feature, just median income, and then I can look at average rooms. Okay, so average rooms, these are like average rooms if there are like this number of features, if this many are the number of rooms you have, and how the median income will look like. Okay, so that's that. And next we'll look into scatter plot. This is similar to what you see in general scatter plots. You will have bunch of data points, and then you will have some base X. So let me run this, you'll understand this better. So what we understand from this specific plot is you will have a single feature, and you'll understand how that feature is interacting with every other features, and how how that interaction is looking like. Okay, so here we have latitude, okay, and its range of values, and then these are like vertical dispersion, which represents all the other features and how it interacts with them. Okay, so that's the whole idea behind this plot. So here we have latitude in range of between 32 to 42 or 44, and then we have bunch of features here. All these are features of other features, okay, and how they are interacting and what is their value, either it is high or low. Okay, so that's how this interaction helps in understanding how one feature interacts with every other feature. And for more, you can read these points. Okay, just pause the video and read these points, you will understand what it is. Now comes the Beeswarm. Okay, this will let you know which is the most important feature in a model, okay, and how it will affect, okay, your final prediction. So let me just run this Beeswarm, and here you have around 8 columns, that is 8 features which are sorted in certain way. If I am not wrong, they are sorted as by the sum of the SHaP values or magnitudes over all samples. Okay, they are the sum of all the SHaP values, all this represents. Okay, now this will also let you know which is the most important for the model. So this is the most important at the top, latitude, longitude, and then the median income. So basically whenever there is the house, okay, the price of the house depends on which area it is located. Okay, so that's why the location is one of the top important priorities given. And then the priority is given to the person who is earning what is the salary he is getting, or what is his income is all about. Okay, so those 3 features are at the top, and these are the rest of those features, okay, which have lesser importance compared to the rest 3. Okay, and you will notice these are like positive, these are like high values, okay, positively impacting all these values. So you can notice here, right, in the bottom, SHaP value impact on model output. So these will have the maximum output impact, and these are also high values. If you see, these are the what do you call it, SHaP values. This is feature values, what we are seeing, right? These are like the color represents the feature values, okay, and this bottom one represents the SHaP values. Next comes the very simple plot of understanding which feature contributes the most, which is similar to this one, what we have seen here. Okay, let me run this one here, which is nothing but average of all the SHaP values for each of the feature. Okay, So for latitude, this is the average SHAP value 0.55, and longitude it is 0.47, then median income 0.39. I think this is similar to this one. Okay, and in terms of the importance, it is the location is at the top priority. Okay, and the SHAP is able to understand the location is the top priority, and then comes the median income. Okay, so yeah, I think we have, like, at the end of the video, we have understood how to use SHAP for understanding the features and how it helps in understanding the final prediction that is happening. Okay, so we have understood only on the tabular data set. In the next set of videos, we'll talk about how we can understand how an transformer model predicts and how an image model predicts based on the features. Okay, so with that, I'll conclude this video. Thank you for watching.